Hey, what's going on, folks? It's Mike here, and welcome to our next lesson in the Modern C++ series. In this lesson, we're going to continue talking about lambdas. So if you haven't seen the previous lessons, make sure to check out the course playlist in the description below so you can follow along. But with that said, let's go ahead and take a look at how do we use lambdas with objects. So in member functions, for instance, if we want to capture this. So with that said, let's just go ahead and take a look at an example so you understand exactly what's going on here. Now, what I'm going to go ahead and do here is just create a new structure here with a member variable and initialize an instance of it. Now, let's go ahead and play around with this struct a little bit and create a function here. I'm just going to call it very conveniently function here. And we'll go ahead and make use of the counter variable here. And let's just go ahead and say what our counter is. And maybe put an end line at the end here. And then maybe call this function a few times on our specific instance here. So our instance, we'll just call function here, and let's just go ahead and call it, I don't know, 4 times just to demonstrate the purpose in this lesson of what's going on here. So I'll go ahead and compile this. I'll use debug symbols, warnings, and treat things as errors just for completion. It's a good habit to have. And let's go ahead and run it. And obviously we're not modifying this counter in any way inside of our actual instance in this member function here from our class. Okay, so with that said here, let's go ahead and use a lambda within this member function, something that you might want to do, for instance, if you're modifying a function or using anything inside of lib algorithm, for instance. So let's go ahead and just create something. I'm just going to call it f here for brevity. Here we'll have a lambda function, and we want to go ahead and do something with counter. Now, again, let's just go ahead and see if I can print out what counter is here. I'm just going to say counter inside lambda, and let's go ahead and spell this out here, and I'll put a colon here, and let's just go ahead and try to print out the counter again, and let's go ahead and compile this. Well, now you're going to get an error here, and this is what today's lesson is all about here. This error message here saying this was not captured for this lambda function. So if I go ahead and bring in CPP reference here, our favorite website here, I'm going to go ahead down to the lambda capture on the lambda page here. And it is showing that, well, if we want to capture for the current instance of the object, that's what we pass into the capture. Okay, so it's actually as simple as that. So we can actually see some of these rules that we've covered in the previous lessons here as well of the different types of things that we want to actually capture. And going down to listing number 7, which I'm going to make just a little bit bigger so folks can see, if you're watching this on a phone, for instance, that this is a simple by reference capture of the current object. And then we can also do a simple by copy capture of the object. Okay, so let's go ahead and look at what this means here, and then we'll go ahead and see how exactly this is useful. Okay, so what I want to do here in the capture is the current instance of this object. I want to be able to capture its member variables. So let's go ahead and try to recompile this again. And well, it looks like it's working here, but our compiler is smart enough to say, well, we're not using this variable f. So let's go ahead and use it. Again, I like using warnings as errors, but we should go ahead and call our function here for our lambda so we can demonstrate the point of this video. Okay, so we see that it's working here, and now I can actually run this program here, and we'll see counter inside of lambda is 0, the counter outside is 0 as well. Okay, so now that we know that we can access the counter here, and we're doing this by reference, again, that was what it says here in listing number 7, simple by reference capture of the current object, we should be able to modify the counter variable here, and that should be able to modify counter, well, inside of this lambda function, so it should report an update here, as well as inside of our class as well. So let's go ahead and recompile this, rerun it, and we can see likewise we get 1, 1, 2, 2, and so on. So we're actually capturing the changes for this instance of the object from this lambda function. Okay, so that's great here. Now let's go ahead and look at the other way that we can capture, which is by value here. And why you might want to do this, again, usually has to relate to, say, if you're doing concurrent programming, and sometimes you don't want to pass a bunch of things by reference, right? You want actual copies. So let's just go ahead and pass in this here. And I'm not going to change anything here, but let's go ahead and see if you can predict what the behavior is. And the behavior is error, because remember, if we're passing something in by value here, and I'm trying to modify it, it's read only by default. And you can go ahead and watch the previous lessons where we push this into CPP Insights, and you'll actually see that this is a const function. So if we want to modify this, we could do something like doing mutable, for instance, and that should allow us to now modify the actual variable within the lambda function. But again, we're modifying a copy here, so it's not actually changing the counter here when we're passing it by value. So just again, keep that in mind. You can review the previous lessons if you need to refresh on that. Now, because we're able to just pass by reference with just this here, and I'll go ahead and get rid of this. Again, that was modifying the actual code here. And something that you will see folks do sometimes is you'll see them say something like pointer equals this or objects equals this. And then you can actually do object, something like this here. Oops, let's go ahead and since I'm using object here, I need to access it like so. Then you can actually refer to the sort of this pointer here. And sometimes it's helpful to give it, you know, a name explicitly, again, to deal with issues of ambiguity if you have variables or other things that might be the same name. So that's just a nice little thing you could do here with your capture if you want. All right, and I will note that, you know, this idea of using some of the things that we've learned about, and let's go ahead and rewind and just put the ampersand, which captures everything by reference. I'm going to go back here. And again, this is recapping or reviewing some of the other things that we learned about. Works just fine as shown here. But we did learn about something like doing equal, which would capture everything by value here. And this has actually been a deprecated feature in C++ 20 here, as the error message is giving us. I mean, we can go ahead and try, if I comment out the thing that I'm removing here, we can go ahead and try to compile this in, say, C++ 17. Let's go ahead and see that this will work. It lets us do that, but that was actually functionality that was removed. So again, I would encourage you to compile with the latest version that is possible and do 20 here. Now, just in case you do need to copy by value here, let's go ahead and go back to 17 here. And we learned that we could do that with, let's see, star this. Let's go ahead and see if that works. Well, that will work here. So if you do need to do that, again, be explicit, I guess, about that you want that actual instance of the object that you're working in to be copied here. So I'll go ahead and compile this. I think that'll be less of an issue if you're following along with this series, or if you have control of your code base. So again, just use 20 so you don't have to worry about some of those deprecated features here. All right, folks, so I hope that shows you something useful for how to capture the actual object that you're working with, or the instance of the object. Now you can use lambdas within your code inside of your classes if you like here. So with that said, folks, thank you for joining me for this lesson and continuing on with the Lambda series and the Modern C++ series here. If you haven't already, make sure you subscribe so that you don't miss any of these lessons that are coming out. And comment below if there's something else that you want to see, some other cool feature of Lambdas, for instance, that you want to learn about, or maybe you know about that you want to share with the rest of the community. As always, thanks for your time, and I'll look forward to seeing you in the next lesson.